So, guys, first of all, we're on question one. Okay, I know it's a bit hard to see. I had to take pictures of it. We don't have the digital copy. So, what I see here is, I'll draw it in green as well. I see z equals 2 plus I. Okay, and I'm going to draw that on the Argand diagram. So I'm going to go 2 across, 1 up, and I'm going to label that as z. Okay. Next thing I'm going to do is I'm going to multiply 2i. I need to multiply 2i by z. So what's going to happen here is 2i times 2 is 4i. 2i multiplied by I is 2i squared. 2i squared is minus 2. So it's minus 2 plus 4i. Or some of you guys wrote it as 4i minus 2. Same thing. Is that alright so far? Yep. So, guys, what we have next is this one here is minus 2 plus 4i. So that is minus 2 plus... I had to multiply 2i by z, and I got minus 2 plus 4i, which is minus 2 across 4 up. Now, please remember, if I was to look at this, if I was to take a rough guess, do you see the way I just drew how close they are to the origin 0, 0? What do you notice about one line compared to the other? What do you notice about one line compared to the other one? One of them is twice as long. That's because you multiplied it by 2. And you also multiplied it by what? You also multiplied it by I. Doesn't it say 2iz in the question? I'm just going to highlight it where it says it. It says it there, 2iz. So that means that you multiplied it by 2 and you rotated it 90 degrees. That's why this here is 90 degrees. If I multiply it by 3i, what would happen? I'd rotate it 90 degrees and it increased by 3 times its original length. If I multiplied it by 5i, 5 times the original length, rotate it 90 degrees. Is that okay? Now, the next one is find the value, and I'll write this down here. It's find the value of 2iz, the modulus of 2iz, all over z. The modulus of z. See those vertical lines there, yeah? That's why a lot of you wouldn't have picked up many marks, even though you did something much more complicated. It says modulus. Can anybody remember what modulus is again? The formula for modulus? Anybody? Real squared plus the imaginary squared. Now let's start off with 2iz. We said that 2iz was minus 2 plus 4i. The real part is minus 2, and the imaginary part is just 4. So I put this in as minus 2 squared plus 4 squared. And what do I get there? Is a root 20? Square root of 20? Or 2 root 5? Same thing, yeah. 2 root 5. Okay. I do the same thing for z, because it says the modulus of z on the bottom. So what is z again? Anybody? Okay. It's 2 plus I, guys. Z equals 2 plus I. I have to get the modulus of that. How do I get the modulus of 2 plus I, anybody? The modulus of 2 plus I? Sorry? 2 squared plus 1 squared. And I will get root 5. Okay? So that's root 5. Now that that's done, what's going to happen next is I have to divide the blue answer by the red answer. And then I'll figure out what that is. So it's going to be 2 root 5 divided by root 5. So 2 root 5 divided by root 5. Anybody tell me what that is? 2 root 5 divided by root 5? 2. What does that mean? 2. One of them is twice as far away from the origin as the other one. Because remember what I said modulus means. Anybody remember what modulus actually means? It means how far are you away from the origin. So, technically speaking, this length here is root 5. The other length here, that's 2 root 5. One of them is twice as long as the other one. Okay? So that's what the next part says. What does the answer in part 2 tell you about the positions of z and 2iz? It tells you that 2iz is twice as far away from the origin as z. Everybody alright with that? Okay. Finally, the last part. It wants me to write down what is 5z bar all over z, and it wants the answer as x plus yi. I want the answer presented as a complex number. To pick up a load of marks here, you don't have to get 100% right. You just need to be able to make a good start. Z is what, guys? What's Z again? Is it 2 plus I? 2 plus I. Can anybody make a good start by telling me what the conjugate is? What's the conjugate? Conjugate is 2 minus I. Whatever happens, you always change the sign in front of the I value. So if it's a plus I, it turns to a minus I. If it's a plus 3i, it changes to a minus 3i. If it's a minus 4i, it changes to a plus 4i. Just change it. Then all you have to do next is this. You just say that equals 5 times the modulus, or sorry, 5 times the conjugate, divided by z, which is 2 plus I. And that in turn will equal 10 minus 5i all over 2 plus I. Would I be happy with that answer? And if not, can anybody explain why? Can anybody explain why I wouldn't stop here? There's a fraction. It wants the answer presented as a regular. It wants the answer presented without any I values on the bottom. So I have to fix that. Does anybody remember how to fix that? You multiply the top and the bottom by the conjugate. Some of you only multiplied the top by the conjugate, and you did multiply the bottom by the conjugate, so that's where you would have lost out. So you have to multiply top and bottom by, what's the conjugate of 2 plus I again? Gotta multiply the top and bottom by 2 minus I. Okay? Please make notes on this if you didn't do it already. 10 times 2, 20. 10 times I minus 10i. Minus 5 times 2, another minus 10i. And then minus 5i multiplied by minus I. Anybody? Plus 5i squared. What is 5i squared? It's 5 multiplied by I squared. And what is I squared? Always minus 1. So 5 times minus 1, minus 5. And then all of that is going to get divided by 2 times 2, 4. 2 times minus I, minus 2i. I'll just draw the lines for you. 1, 2, 3, 4. Okay? And then it's plus 2i. And then it's minus I squared. What's minus I squared, anybody? Minus minus 1, which is plus 1. On the top we have what? We have 20 minus 5, 15, minus 10i minus another 10i. 20i all over. 2 them cancel, and that's a 5. And that will get you 3 minus 4i. Listen, even if you just write down the conjugate, and you do top and bottom by the conjugate, and you don't really get much further, you're still well in the 60 to 70 region somewhere. Okay? So that's a pretty hard question. So 3 minus 4i, who got that? Anybody get that? 3 minus 4i? Okay. Alright, moving on, guys. This one here. 340 as a product. Can anybody tell me what product means? Multiply it by each other. So as an example, if I had 12 and I want you to write that as a product of two numbers, I could write it as 3 multiplied by 4. I could write it as 6 multiplied by 2. Something like that. Would you agree? Okay. And that's a product. If it says sum, what does sum mean? Anybody tell me what sum means? Add it together. So if I want to write 12 as a sum, I'd say 6 plus 6. Or I'd say 3 plus 3 plus 3 plus 3. That's a sum, that's a product. Now, it also wants prime factors. Can anybody tell me what are the prime numbers? What's the first prime number? 2. 3. 4 is not a prime number. 5. 7. 11. 13. I think we can pretty much stop there then. 7 in the next one. Now, what you do is just pick any two numbers that will make 34 or 340. I'd start off with 34 and multiply by 10. You could choose something else, it doesn't really matter. Neither one of these are prime, are they? So what can you break 34 up into? 34 is an even number, so what is guaranteed to go into it? 17 and 2. 2 by 17. What's guaranteed about 10? 10's not a prime number either. What can I break that up into? 2 by 5. And then how many 2's do I have? So you can write that as 2 squared multiplied by 5 multiplied by 17. Now, there's also a button that does that for you. Alright? If you don't remember that, you can always do this. 340. You might not remember it on the day, so it's important you have both ways. Shift, see the factorize button? 2 squared 5 by 17. I know, but you should probably understand what it means. It breaks it up into smaller parts. It still equals 340 when you multiply it all out. Yes, Sean? I broke up, I looked at the 34 and I broke it up into 2 multiplied by 17. I looked at the 10 and broke that up into 2 multiplied by 5. And then I combined the full answer together. See the way I have 2 twice? See the way I have it here and here? That's 2 of them, so that's why it's 2 squared. 2 squared means 2 multiplied by 2, multiplied by 5, multiplied by 17. It doesn't matter what order I put them in, once they're all there. Yeah, 2, 5 and 17. 2 twice, 5 once, 17 once. Okay. The next one is, for each of the numbers in the table, state if it's rational or not. Well, I showed you a bit of a cheat way to do this. What did I show you in the past? Just put into the calculator, and if it comes out as a fraction or a whole number, it's definitely rational. So this one here is rational, and it is a quarter. Okay, I'll just start off with a tick. I'll just tick them off as rational and irrational at the moment. Okay. 5 pi over 4, anybody? Take a guess. Okay, because pi is a irrational number. So look at that. There's no pattern. There's no fraction. So that means irrational. Root 2. It's irrational. 1.3 with a dot above it. What does 1.3 with a dot above it mean? It means there's a pattern. Okay? And it's actually 4 divided by 3. See the 1.3 with the dot on top of it? That means the 3's go on forever. So that means it actually can be expressed as a fraction. So if you see those tiny little dots on top, it actually means that it's a rational number. Yes? How do you know what is a rational number? A rational number is... So lads, next thing is this one here, 12.5%. What do you think of 12.5%? Rational or irrational? It's rational, 12.5. It's a decimal, alright, but there's no irregular pattern or anything like that. If you wrote 12.5 in your calculator, now the interesting thing about percentage, what does percentage mean? Out of 100. So it's actually 12.5 divided by 100, which is 1 over 8. So it would be a rational number. Now that's what does it want me to do next? Write each of the irrational numbers. Alright, so it wants me to write the rational numbers as a fraction, and it wants me to write the irrational numbers as a decimal. So that's a quarter. That's 4 over 3, because it's 1 1/3. And this one here, I just did in my calculator a second ago, 12.5 divided by 100 is 1 over 8. The next step then is to put the irrational numbers as decimals to 2 decimal places. So 5 pi over 4 is going to be 3.93, and then the other one, root 2, I think it's 1.41, 1.41, and that's me done. Some used threw in a few extra, but it didn't really affect the marking scheme. Next one. Lads, next one. See this number here, yeah? You can do this 2 ways, okay? I thoroughly recommend just going straight into science mode. I think it's the best way to handle anything like this. And then you just write down 299, 792, 548. You press equals, and you get this number here. What does that mean? It means if you were to multiply 2.99 by 10 8 times in a row, by 10, multiply by 10, multiply by 10, multiply by 10, do it 8 times, you will get this number here. Alright? Now, to round it off, 2.99 very close to 3. So it actually like it rounds off to one significant figure, which is 3 by 10 to the 8th. Can everybody, regardless of what you know, just just look up for 1 minute, okay? I just want to clear up what significant figures actually means, okay? Because I often forget, so I'm going to admit as well. If I have 52,000, how many significant figures is that? It's actually 2. If I have 60,000 significant figures, is that? 1. If I have 50,002, how many significant figures is that? It's actually because the zero sandwiched in between. Every number matters. So for significant numbers, guys, I really need you to focus in on this. The zeros don't matter when they're all at the end together. But when the zeros are in a sandwich between two numbers that aren't 0, then all of a sudden they matter. Okay? So all of a sudden they matter. I'm going to give you one more, alright? What if I said 200,000? How many significant figures is that? 1. 200,000 and... let me see. This one here. It's actually 4 because that's your sandwich there. And the 2 zeros at the end don't matter. Now, unfortunately enough, I now have to bring you on to decimal significant figures, okay? So decimal significant figures would be done like this. If you have 0.0001, how many significant figures is that? Just 1. 1 at the end. Okay? If I did it like this, 0.3, how many significant figures are there? Just 1, the 0.3. If I did it like this, 1.3, how many? 1.03. 3 because the 0 is in a sandwich. 0.0309. 3, the 309. Okay? Is that alright? Significant figures they're temperamental. Okay? You just gotta be aware of both types. Okay? Now, this one here, I think this was relatively easy marks for most people. Okay, what time are we at? Okay, we're doing well. Okay guys, so 3 multiplied by 2x minus 5. 3 multiplied by 2x, 6x. 3 multiplied by minus 5, minus 15. Plus 7x is smaller than 11. Shh. Okay. Now, 6x, 7x, 13x. Bring the 15 over the other side. 11 plus 15, 26. Divide 26 by 13. X is a smaller number than... You only change the sign around when you multiply both sides by minus 1. Do not multiply both sides by minus 1. You do not have any need to change the sign around. Is that okay? I'll explain the general rules. Please pay attention here, right? If 7 is bigger than 6, would you agree with that? If I change the 6 and the 7, if I switch them with each other without changing the sign, what happens then? Sign has to change around the other way. Okay. If I multiply both sides by minus 1, what happens? No, sign has to change as well. If I just swap them, but like, as in, if I bring this over this side and turn it to a minus 6, I bring that one over the other side and turn it to a minus 7. Actually stays the same. So they're the little tricks you gotta be familiar with. Okay? When you multiply both sides by minus 1, or even if you multiply one side by minus 1, it generally changes sides. Otherwise, you can bring them over, like you can treat them like an equal sign and you don't have to change anything. It's only when you multiply both sides by minus 1, or you decide to swap both of them without changing the sign, do you have to change the sign. Okay. Next one is a fraction question, right guys? So I just want to bring it to a really basic fraction. If I asked you to do this without the use of a calculator, what would you tell me? It's not cross multiplying because it's not an equal sign. what you do is you're finding the lowest common denominator. You multiply this by 5 top and bottom, and you multiply this by 3 top and bottom. And you're going to get 5 times 1 is 5 over 15 minus 6 over 15. You basically look to you look the denominator, the 3 looks at 5 and says, I'll put a 5 top and bottom. The 5 looks at the 3 and says, okay, I'll put a 3 top and bottom. This is the exact same procedure here. And you get a mammoth load of marks just for getting the common denominator. So anytime you're faced with a question like this, where it's 4 over x plus 4 minus 3 over 2x minus 1, all we got to do is this. Look at the denominator on the other one and write it top and bottom. Like that. Then same trick for the other one. Look at the denominator of the other side and you can say, okay, that's x plus 4 and that's x plus 4 on top. Because there's no equal sign, the bottom has to stay in your answer. The bottom just can't disappear because it's a fraction answer. Like, do you know, if you had an answer of 3/7, you can't just say the 7s aren't there. The answer is 3/7. You can't get rid of the bottom. So there's no way to get rid of the bottom as it currently stands. Okay? So what you do next is you multiply it out and you get a 8x and then minus 4. And then it's 3 times minus 3x, and then minus 3 times 4 is minus 12. Keep the denominator exactly the same. And what do we have here? 8x minus 3x, 5x minus 16. Are we alright with that? Now, next part. Show that this last question equals to 1 has no real solutions. Okay, no real solutions means you're not going to be able to do this question. Even when you do it properly, you'll find that eventually you won't be able to get an answer. That's the point. So what's going to happen is this box here is the answer to the last question. The answer to the last question is 5x minus 16 all over 2x minus 1 all over x plus 4. Everybody happy with that? What's the current problem with both sides? Do they have the same denominator? Any way of giving them the same denominator? Huh? How do we give them? Multiply the top and the bottom by the same amounts and you don't affect it. Do they have the same denominator now? Am I able to cancel the bottoms in this case? Why am I bottoms for this question? It's a solved question and it has an equals in it. Now I'm allowed to cancel bottoms. So that one here with this one here, because they're exactly the same. All I gotta do now is multiply it out. Okay, multiply it out. I'm gonna get 5x minus 16 equals the 1 there, because 1 times anything is exactly the same number. 2x times x, 2x squared. 2x 4, 8x minus 1 times x minus 1x minus 1 times 4 minus 4. Still haven't made a single mistake yet. Bring over the 16 and the 5x over the other side. I'm going to get 2x squared, or 0 equals 2x squared. What's x minus 1x? And then x is going to be over the other side alongside it now. So x. And then we're going to have minus 4 plus 16. What's minus 4 plus 16? Plus 12. See this equals 6. Does that have to be on the left? Can it be on the right? Okay. If I had 4 plus 1 equals 5. Matter if I say 5 equals 4 plus 1. Doesn't matter which side it's on. They're equal to each other anyway, so it doesn't really matter. So, can anybody guess something that might make it easier? Divided by 2. You even have to, but it works that way. And what you're going to notice is that you can't get a reference number to answer this. It's not going to work. So we go for the minus b formula. A, B is C. What's the A value? 1. The B value? C value. Okay. Anybody tell me what's going to happen to prevent me from getting an answer? And where's the error going to occur? This is going to be a negative number. When it's a negative number, it means that I can't get the answer out. It means that there's no answer to this question. That's what I'm expecting to happen. Minus 1 plus or minus the square root of b squared, which is 1 squared minus 4 1 6 all over 2 times 1. Okay, go to the calculator. What I've always taught you guys is to use the square root sign first. So we go for 1 squared minus 4 bracket 1 bracket 6 equals maths error. Okay? If I took away the square root sign, we were expecting, you could just write, you could chance your arm at maths error, can't get the answer out, there's no solution. I'd personally do it like, wait a minute. I'm still in scientific mode, so I'm going back to normal mode. Minus 23. So minus 1 plus or minus the square root of minus 23. And what do you say then, guys? Not a real number. No solution. Okay? No solution.